Hi everyone, I'd like to welcome you to the next lecture for the module CO452 Programming Concepts. In this lecture, we're going to take a look at the fundamental construct of selection and enumerate types. So let's start with selection. Now, selection is one of the fundamental constructs of programming languages like sequence and iteration. Now, so far we've probably seen sequence, where lines of code execute in order from the top of the file and execute one line after another in an orderly sequence. And next week, we're going to have a look at iteration, where we can have a look at repeating statements. Okay, but this week, we're going to take a look at the other construct, which is selection, allowing us to select between blocks of code based upon whether a condition is true or false. Okay, and this week we're going to take a look at two ways to implement selection in our programs. We're going to have a look at the if, else if, and else blocks, and we'll also take a look at the switch statement as well. So let's start with the if statement. The if statement is fairly simple in its premise. It basically says, if this comparison is true, then perform this code. Okay, so if this is true, do this. So here is where we would provide a comparison of some kind to evaluate whether or not we want to perform a piece of code. So in this case, we're testing to see if the value of mark, this variable, we can assume it's an integer, if the value of that is less than 0, then if that is true, then perform this piece of code that's placed within the braces here. So this is where we section off the code that we want to execute if the condition is true. So if the value of mark was, say, -1, is -1 less than 0? Yes, it is. That's true. So therefore, print out this message to say that the mark must be greater than 0. Okay? And we can also combine if statements. We can have multiple if statements in our programs. In this case, they're one after another. So we can first of all test the value of a mark to see if it's less than 0. So if it's -1, then we would print out this message within this block, these pair of braces. And then we could test the mark again to see whether it's greater than 100. So it could be the case that the first mark may check out. For example, if mark had the value of, say, 101, well, that's not less than 0 in the first test. Okay, it's greater than 0. So therefore, the evaluation of that comparison is false. But in the next comparison, mark, if it was 101, is greater than 100. Therefore, we would execute the statement which prints out a message to say that mark must be less than 100. Okay, this is the logic that we are defining for our program. Mark has to be between the value of 0 and 100. Okay. So let's have a look at some other operators that we can use to perform comparison. Okay, so equality, a check for equality would use two equal signs. Now, we're probably used to using one equal sign to assign a value on the right-hand side of the assignment operator, the equal sign, to the storage area on the left-hand side. But if we use two equal signs, one after another, that then compares left-hand and right-hand sides. Okay, so it checks to see, do they have the same value? In the case of integers, that's fairly easy to check. We can see whether the left-hand value, maybe it's a variable. Let's see if mark has this value, then we can do something as a result. Okay, so that's equality. And then we have inequality to check to see whether they are not equal. So if we previously used equality to check whether they have the same value, inequality is the reverse of that. It's checking to see whether they are not equal. So as I say, if you used equality and the result was true, then if you used inequality, the result would then be false because it's not equal. It's the reverse of that, okay? So that's inequality, checking to see whether the two values are not the same. So if I had a different value on both hands of the inequality operator, then the result would be true because they are not equal, okay? We've already seen greater than and less than. That's just checking to see whether one value is greater than the other or less than the other. But we can also combine that with greater than or equal to. So we can combine both the equality operator and the greater than or less than operators. So that's useful if you want to check to see whether a certain boundary value needs to be included within that. Or alternatively, you could actually just subtract one, add one, depending on what side you want, from the value, and then use greater than or less than. So there are different ways of checking, depending on your scenario and what logic you're trying to enforce within your programs. Okay, so those are comparison operators. They need a left-hand value and a right-hand value to compare. And the result will either be true or false, by the way. It's binary, a binary choice. But there is an exception with using strings. So equality, the two equal signs, would work for primitive data types, such as integer, char, boolean. But when we talk about strings, we've actually got another lecture prepared for talking about strings. Strings, remember, they start with an uppercase letter, capital S, so that implies it's a class, so it's different technically from a primitive data type. And we have objects of the string class. So if we were to use the equality operator on these string objects, rather than checking the value inside of the string, which is basically a character array, the combination of letters and numbers we want to store in our string, rather than checking that, the equality operator would actually look at the memory address for which those values are stored at. So remember, when we declare objects, we use the keyword new, and that tells the compiler to allocate memory on the heap. It requires it to create a memory address on the heap and set up a reference to that. So it would actually look at the memory address rather than the value. So handily, there is a method, it's part of the string library, called equals, that we can use instead of the comparison operator, the equality operator, two equal signs. And the equals method will check the value inside of the string. So you notice here, we just need to call the equals method on a string object, and then the parameters as between the parentheses is what we want to pass the value that we want to then check whether it is equal to that or not. So in this case, if I had a string variable called name and I wanted to check whether it had the value of Nick with a capital N to start with, the formatting here would be calling the equals operator on that string variable name if name.equals has the value of Nick, and I pass that as a string literal to the equals method. Okay, so just remember that for string equality, use the equals method rather than the equality operator. But for all other data types, primitive data types, we can use the equality operator. Okay, so let's move on to logical operators now. And logical operators allow us to combine comparisons. So you remember in the slides before, we saw one if statement after another. With logical operators, I could combine those within one if statement, potentially. Depending on the scenario, of course, and what I want to check and what I want to perform. But if I was to combine multiple comparisons with the AND operator, which is the two ampersands, which is actually the symbol above your 7 number, the 7 key on your keyboard. Okay, so it's holding shift and then pressing 7 to get to it. If you use that, two of those ampersands in between two separate comparisons, that would require all of the comparisons to be true in order to execute the code in the if statement. Okay, or if you have more than 2 comparisons, it would require all of them to be true. So you could potentially chain even more, 3, 4, 5, 6, however many you require. And then the OR operator on the flip side is 2 vertical lines, and that is the key in between the shift key and the Z letter on your keyboard. And again, you need to hold down Shift and then press that key on the keyboard there, which is on the left-hand side of the Z, to get that vertical line. And that is the OR operator. If you use that to combine multiple conditions, that means that only one of those comparisons has to be true in order to execute the code in the if statement. Okay, so that will change the logic of your scenario, of your program, depending on which one you use. And then we also see the exclamation mark again. Remember the inequality operator? It's the same principle here, where we could place the exclamation mark in front of a series of comparisons to then reverse the evaluation of that comparison. Okay, so let's have a look at an example of using the OR operator. So in this case, we're going to combine those two separate if statements that we had on a previous slide into one, and we're going to join them essentially with the OR operator. So place the two vertical lines in between both comparisons, and it's worth stressing that you do need both sides of the comparison, remember. You need both a left hand and a right hand value. You wouldn't be able to say mark less than 0 or greater than 100. You would need to specify mark again to have the comparison between the two left hand and right hand side of the operator. Okay, so first of all, work out, well, check, is mark less than 0? Is that true? Or is mark greater than 100? If either of those are true, then we execute the line of code in the if statement, which in this case prints out the message, mark must be between 0 and 100. And it's worth stressing here, of course, that the mark cannot simultaneously be less than 0 and also greater than 100 at the same time. It will either be one or the other, won't it? So it'll either be like -1, which is less than 0, or be 101, which is greater than 0. It can't fulfill both at the same time. So for checking items outside of the range, you would usually use the OR operator. As to say, it's either going to be one or the other. But if you're checking for items within a range, you would tend to use the AND operator, because that will fulfill both at the same time. If at a mark of 50, that will simultaneously be greater than or equal to 0 and also less than or equal to 100. Okay, so the AND operator requires all of those comparisons to be true, which, as we just said, a mark that fits within that range would fulfill both of those comparisons. Okay, so that would then print out the message, this is a valid mark. Okay, so there's just two helpful logical operators there to combine multiple comparisons. So let's now move on and have a look at the counterparts to the if statement, which are the else block and the else if block. So else statement means that, well, if the initial comparison of the if statement was false, then execute something else. So basically, we're defining another block of code to run if the evaluation of the if statement was false. So basically, if mark fits between 0 and 100, execute this block of code, which just outputs it's a valid mark. But if that's not true, then print out instead that this is an invalid mark. Okay, you notice there's also no comparison taking place on the else, because remember, we've got a binary choice. It's only either going to be true or false. So if it's not true, then it must be false. Okay, that's why we don't have to place parentheses there with a comparison. All right. We can then also insert else if statements in between the if and the else statements. Okay, so here we've expanded the scenario basically to print out custom messages which will print out what grade they got. And of course, this is the UK higher education grading system, the degree classifications here. So if the mark fits between the value of 0 and 39, print out the message, this is a failed attempt. And then else if, basically if it's not, if the initial if comparison was false, then try this one, check this one. Well, if mark is less than 49, well, it's got to be greater than 39. It's got to be 40 or more. And if it's 40 or less than 49, it must therefore be a pass, because remember we failed the initial one. If that was false, then we then go down to the else if and check whether that's true. If that's false, we then go down to the else if again. Remember, if that was false, the else if, then it must be greater than 50 or greater, and it must also now be less than 59. And if that's true, if it's something like 55, that's less than 59, then we would print out the message, well, you got a 2, a lower second. And then we check the rest. Is it less than 69? Is it less than or equal to 100? And remember, 100's the upper limit for a standard assignment or exam, 100 marks. So we check each one in turn, assuming that the one above was false in order to then come down to the next one. Okay, and then the final else assumes all of the above are false, and then if it's not any of those values, then print out this must be an invalid mark. Okay, it's either going to be less than 0 or greater than 100. Okay, so here's where we can define very specific messages for different bands of values for our marks, okay? And the interesting thing here, I don't know if you notice, we aren't using braces. We've removed the braces, which would kind of contain the block of code which we want to execute, depending on whether the condition is true or false. You notice here we're not using them, and this is an exception to the conditional statements and also iterative statements as well. If we've only got one statement within the body, we don't have to have a pair of braces. But if we have 2 or more statements, then we are required to specify these within a pair of braces. Okay, so this is just for neatness here. Just save space in your code. Oh, okay, and yeah, we can take it further as well. Rather than using literal values, we can actually state these upper boundaries to be constant, which is good practice, of course, because they never change. So we can specify constants for all of the upper limits of certain grade boundaries. Remember, for constants in Java, we need to use the keyword final. And again, uppercase for the name of our constants, remember. And also we're using the underscore just to read it a bit better. So we can replace those literal values in our else if ladder with these constants. Okay, so it's the same logic, but because those values never change, we can just declare them to be constants. Okay, it's good practice there. All right, so that was the if statements. Let's now have a look at an alternative way of implementing selection, which is the switch statement. Now, the switch statement is still going to offer selection between different pieces of code. However, it has a slightly different syntax because we have to place the variable that we want to test, that we want to compare against certain values. We have to place those in cases. That's a keyword, a case that we need to define. So it lends itself to a variable which has a limited number of defined values. So we're going to see an example in a moment which uses a letter grades. And it checks each case in sequence, testing the value which was in the variable against each case. And if one of them is true, then it executes the code associated with it. You'll see a colon indicating which kind of associates the code that needs to be executed with the case that you're testing. And then at the end of the switch statement, you'll see the default keyword being used. And that's the equivalent of the else part. So basically meaning if all of the above are false, if none of them match, then we can execute a piece of code which will be the equivalent of else. Okay. However, there's a strange part to the switch statement in that the way it's coded, if one of the cases matches, then it would then proceed to execute all of the other cases below the true one, regardless of whether those additional cases are true or false. And this is known as the fall-through mechanism. You see some switch statements coded to guard against that, they may have flipped the order around, started with, say, maybe the lowest values first, and then ascend to the highest values. So there is a way to make use of the fall-through mechanism, basically meaning putting the conditions where you think will be true nearer the bottom, so that when it falls through, it doesn't then execute lines below it, depending on your scenario, of course. But an alternative to that is using the break statement, or you could say keyword, coding the break keyword and then following that by a semicolon. That would jump out of the block of code where the cases are defined. So let's have a look at the example here. This might make a bit more sense. So notice here we've defined a grade variable. It's of type char, character. And here's where we use the switch keyword. And then we've got parentheses there, and we place the variable grade within those parentheses. And then we open the block, and there's where we define our cases. And as their characters, we're comparing them against the literal characters of F, D, C, B, and A. If one of those matches, then we print out the corresponding grade classification. And then there's that break keyword with a semicolon. So that's where we break out of this block of code to prevent then executing all of the other false cases. Okay. And then you'll see at the very end, we've got the default case. Again, that's our else part. So if all of the above are false, then this therefore must be an invalid mark. Of course, assuming we are working with a limited number of true cases. So it lends itself to data which has a limited number of values. Okay, so that's an alternative method to implement selection. Let's now finish up with talking about the enumerate type, which follows on quite nicely from switch, because the enumerate type is where we can define a type which has a limited number of values. So, for example, like letter grades, where they will only have values between A and F, we can specify a user-defined type just for those values. Okay, and this makes validation a bit easier as well, because we don't then have to check against values outside of that range. We only then have to check for values within that range. Okay, so any group of data or items which have a limited defined number of values lends itself quite nicely to creating an enumerate type for that. So how do we do that? Well, we can define what looks to be similar to a class. You'll see in a moment when we look at the next slide how we can have variables and methods for our enumeration. Here's a very basic version of it, where you notice we state public. We have to use the keyword enum there. And then notice grades, it's plural, has an uppercase G. So again, the symbolism here, of course, is that uppercase first letters lend themselves to classes. So we are starting to see, hopefully, that this is going to form part of a class. And indeed, you'll see it pop up on the BlueJ window as well with your other classes. It will probably say enumeration or enum underneath it, just to distinguish it from a class, but it does have class attributes and behaviors there. And in this basic example, what we define between the braces here are the values themselves for the enumeration, which are our letter grades in this case. And notice they're separated by a comma. And then at the very end, we've got a semicolon just to finish the list. Okay. And if we don't specify values for these values, they would be assigned integer values by default. So starting from the first defined enumerate type, the value for that, NS would have the value of the integer value of 0, and then it would increment from then on. So you see A has the integer value of 5 there. Okay, let's have a look at an extended version of this, where we can assign different values, more meaningful values for these letter grades, which you notice here are the upper bounds for them. Okay, but to do this, we have to change the implementation of the enumeration here, because you notice that we have got a constructor as well as an variable or an attribute of this enumerate type, which is looking now very similar to a class, isn't it? And you notice, interestingly, that the constructor, the scope of it is private. Now, we're used to seeing the constructor as being public, usually, because it's called outside of the class it's defined in. When we create an object of a class, that then calls the constructor within the class, but we create the object outside of the class, usually. But here, when we place the integer value for the corresponding enumerate type values, ns to a, when we place those integer values in between a pair of brackets, parentheses, that is an implicit call to the enumerate constructor. Okay, so that 0 for ns is passed into the enumerate constructor value and is then set to the private member, the variable, the attribute of this class. So it's an internal call to assign the value for it. Okay, that's why we've added this code, so that we can internally assign custom values for these enumerations. Okay, so this is going to be called internally, hence why these are private. Okay, but we have also got a public method at the bottom there, getValue, which we are going to call outside of this class, and you'll see that on the next slide, which just returns the value for the enumerate value. Okay, so let's have a look at that. So last slide, here we have replaced those constants, well, and also the actual literal grade boundaries with the call to the getValue method of particular enumerate values. So grades.ns, the ns value of this enumeration, we call the getValue, which returns the integer for it, which would be 0 in this case, so that we can then compare against the integer, which is mark. Okay, so that's how we can use enumerations within the context of comparisons with integers. Okay, so that will perform the same as the constants here to print out the appropriate message for the grade that we got. Okay, so that brings us to the end of this lecture. I hope that was beneficial. I will see you in the next lecture.